Hello my dear friends, today we will talk about how to present the data graphically, and the graphs which we are talking today are the cumulative frequency graph and the cumulative percentage curve, which is also known by the name ogive. So, whether I say ogive or I say cumulative percentage curve, it is one and the same thing. Now, first question arises that why we present the data through the graph. What is the importance of the graph in analysis? When I say data, what do I mean by data? Data means the numbers, the information which you are gathering in your study, in your research, in your findings. You have conducted a research on, you have given a test to 100 students and the marks are 30, 40, 50, 70, 80. So, this 30, 40, 70, 80 will be called my data. And this data comes in the quantitative measurement, that is when the numbers are counted. Now, since I am talking about the data, the quantitative, I tell you, this measurement will be done by two types, qualitative and quantitative. Qualitative means quality, good, bad, small, short, poor, rich, intelligent, average. This is a qualitative. 100%, 90%, 10 rupees, 1 lakh rupees. When I put the number, it becomes a numerical figure, it becomes a quantitative data. And this quantitative data is to be analyzed for the further inferences, to draw the conclusions and to conclude what is the finding of the research. Now, as I told you quantitative, just I take you 1 minute and tell you in quantitative even can be divided into two parts. One is discrete, the second is continuous. The number which cannot be subdivided is called discrete, and the numbers which can be further subdivided is called continuous quantitative measurement. Now, discrete which cannot be further subdivided, for example, if I say there are two friends, I say tell me about your family. A says, sir, my family is small. The other say, no, sir, my family is big. It is a qualitative. A says that there are 4 members in my family, and B says there are 30 members in my family, 40, 30, 20, whatever he says in my family. Now, family members are 1, 2, 3, 4. The gap between 1 and 2 cannot be further subdivided. It is discrete. How many players play in the cricket? 11. 1, 2, 3, 4, 7. The gap between 1 and 2 cannot be further subdivided. So, it will become the discrete. What is continuous? You draw 2 lines, 1 inch, 2 inch, 1 centimeter, 2 centimeter. Now, gap between 1 inch and 2 inch, 1.1, 1.2, 1.3, you go up to 1.9, it will convert into 2. It is a continuous. Time, 1 minute, 1 second, 2 second, 3 second, clear? Rupees, 1 rupees, 1 paisa, 1 rupee, 2 paisa. Weight, 1 kg, 1 gram, 2 gram, 3 gram, 4 gram, you can even go to milligram. So, these are continuous. Time, money, weight, length, these numbers can be further subdivided. So, when number comes to us, we make the statistical analysis. We calculate correlation, T, chi-square, analysis of variance, mean, median, dispersion, etc. But what is the use of these graphs? Why we are making the graphs? If we make the graphs, no doubt about it, it gives a aesthetic look to the presentation. That's fine. I am not concerned about aesthetic look. I am concerned about if the data is presented in the form of graph, it is easy to understand. Without going through the statistical process, it will give me a meaning, it will give me a sense that what does it mean. So, understanding interpretation becomes easy and more meaningful when the graphs are drawn, in addition to your aesthetic look. Now, in my first video when I presented the graphs before you, I talked about 3 types of the graphs. One was a bar diagram, the second was a polygon, and the third was a histogram. What is bar diagram? What was the bar diagram? Where you have more than 2 groups, more than 2 groups, 2, 3, 4, 7, 8, 9, 10, so many groups are there. So many groups are there before you, and you have calculated the mean, the number of accidents in 2000, 40, in a city 2001, 30, 2002, from 2000 to 2023. So, we have 23 groups, fine, 23 conditions. So, if I start reading the data, it becomes difficult. I put a bar, I demonstrated in my previous video. So, if you made the bars, it will give me the look which is the hike, where is the maximum hike, maximum accident occur here, which is at the low level, accident the number of accidents in this year was very low. So, that was a bar diagram. Then we talked about the polygon. Poly means many, gon means angle, many angle diagram. So, polygon was I have presented that through a figure also in my last video. Polygon is drawn on the mid value of the class interval. On the OX axis we take the class intervals, and on the OY axis we take the frequencies, and then we on the midpoint we draw that was a polygon. Then there was a histogram. Now, histogram is not drawn on the midpoint, histogram is drawn on the complete class interval. Same OX axis class interval, OY axis we will take the frequencies. Now, after the frequency polygon, two type of the new graphs emerge. They are cumulative frequency graph and the cumulative percentage curve are the type. Now, first I will talk about the cumulative frequency graph. The cumulative frequency graph is another way of representing a frequency distribution of a diagram. Before plotting the graph, the scores of the distribution must be added serially or cumulated. You see, when we say cumulative, when we say frequency, that means we are talking of the data which is in the form of the group data. Class interval frequency 140 to 144 there are 10 students, 145 to 149 there are 5 students, like on. So, when the data is in the form of the group form frequency distribution class interval, then to plot this graph, which graph? The cumulative frequency graph, we will first add the frequencies serially or cumulative. For example, I am presenting a data before you. The data is 140, 144, 145, 149, 150, 154, 155, 159, 160, 164, 165, 169, 170, 174, 175, 179, 180, 184, 185, 189, 190, 194 and 195 to 199. Lowest is 140 to 144, highest is 195 to 199. The respective frequencies, if I start from the bottom, from the top, it is 1, 2, 4, 5, 8, 10, 6, 4, 4, 2, 3, 1. So, this is your frequency. Now, since it is a cumulative frequency graph, so we will first of all do the cumulation of the frequency, we will add up. What do you mean by cumulation? You know, together. We are accumulating money, we are collecting, adding money. We are teachers, we are not adding money, we are adding frequencies. So, that is why it is called cumulative frequency. Now, we will start from the score which is the at the lowest, not lowest end, which is of the lowest value. The lowest value is 140 to 144. You see, its frequency is 1, 1 is 1, nothing can be added because nothing is below it. Now, next 145 to 149 frequency is 3. Now, I will add this 3 in 1, 1 plus 3 is equal to 4. So, 140, 49 cumulative frequency 4. Then next is 2, 4 plus 2 6, next is 4, 6 plus 4 10, again it is 4, 10 plus 4 14, 6, 14 plus 6 20, then 10, 20 plus 10 30, then 8, 30 plus 8 38, then 5, 38 plus 5 43, then 4, 43 plus 4 47, then 9, 47 plus 2 49 and then 1 49 plus 1 50. You know the total frequency was 50, the cumulative highest is coming 50. So, it is cross checked, nothing, no mistake has happened. So, first step will be you will calculate, you will find out the cumulative frequencies starting right from the class interval which has the lowest value. Then I have given the upper limit 144 to 140 to 144, the upper limit of this class interval is 144 to 144.5. Then 144 to 149, 149.5. What does mean upper limit? Upper limit means that this score can go up to higher level up to what extent? If I say 144.6, it will convert into 145 mathematically. That means 144 can go maximum up to 144.1, 144.2, 144.3, 144.4 and 144.5. Once it is 144.6, it will be 146. So, upper limit is 144.5. This is the logic. But if you are to calculate determined, if you want to calculate the upper limit of any score, add plus 5, 0.5, and if you are to find the lower limit, subtract 0.5, clear. So, upper limit, add 0.5. So, first of all you calculate the cumulative frequencies and determine the upper limit of the class interval. Now, in plotting the frequency polygon, the frequency on each interval is taken at the midpoint of the class interval, but in constructing a cumulative frequency curve, each cumulative frequency is plotted at the exact upper limit of the class interval upon which it falls. This is because in adding progressively from the bottom up, I am saying bottom up, each cumulative frequency carries through to the exact upper limit of the interval. The first point on the curve is 1 y units. The cumulative frequency of 144 to 144 above is 144.5. The second point is for y units above 149.5. The third is 6 units above 154.5 and so on. The plotted points are joined together, then an S-shaped cumulative frequency graph is obtained. In order to have the curve begin on x-axis, it is started from 139.5, exact upper limit of the 134 to 139, the cumulative frequency is 0. Now, what does it mean? Now, you see the graph. Now, the graph is before you. Just before few minutes or in the frequency polygon, I told you that frequency polygon is always drawn on the mid value of the class interval, mid value of the class interval. If the class interval is 140 to 144, the mid value will be 142. So, I will not make the graph on 140 or 144, I will lift from 142, but in the cumulative frequency graph, it is not drawn on the mid value, it is drawn on the upper limit of the class interval. That is why we determined upper limits of the class intervals. You might have seen we calculated the upper limits 144, 149.5, clear. So, with these upper limits, now we will make the graph. Now, one score below it, the lowest value was, you see, lowest value was 144 to 140 or 40 to 144. Now, before below it will be 135 to 139. So, I will assume 135 to 139. Why? I have told you earlier, but I will again repeat it. Now, 135 to 139. Why 135 to 139? Because the graph should always start from the base value. The first class interval 140 to 144 has the frequency 2. So, if we start from the frequency, now where is cumulative frequency? Here cumulative frequency 5, 10, 11, whatever it is, it will hang in the air. So, I will start from the 135 to 139, there is no frequency. So, frequency is 0. So, what I have done? I have assumed 135 to 39 frequency is 0. So, the graph will be with the baseline. So, just to get the graph on the baseline, we take one class interval of the lower, which is of the from the bottom, and then you are looking the gap. Gap means all the class intervals before 134 are immersed in this gap. Otherwise, it's 0 to 4, 5 to 9, unnecessary wastage of time, space, and it will be more imbalanced or inappropriate graph. Now, the cumulative frequency of the first class interval was 1. So, you see 144 to 145, this is 144 to 144, this is 144.5, 1, just take 1, then take the second. What was the cumulative frequency? Then next. So, take the cumulative frequencies and put the points and you join, it will become your cumulative frequency graph. So, difference between polygon and cumulative frequency is that polygon is drawn on number 1 on the actual frequency, on the frequencies with the mid value of the class interval, whereas cumulative frequency graph is not drawn on the mid value, it is drawn on the upper limit of the class interval. The second type of the graph is cumulative percentage curve. You say it is also known by the name ogive. Now, it is different from the earlier graph which I talked about just now. What is this? The cumulative percentage curve or ogive differs from the cumulative frequency graph in that frequencies are expressed as cumulative percentage of n on the y axis instead of cumulative frequencies. Now, in the cumulative frequency graph, we did not took cumulative percentage, we only took cumulative frequency 1, 2, 3, 3 plus 4, 7, 7 plus 8, whatever it was. Now, in this graph, we will not take the cumulative, we will take the cumulative percentage. That is why it is written the cumulative percentage graph or the ogive differs from the cumulative frequency graph in that frequencies are expressed as cumulative percents of n. What is total number of n? N means the total number of students cases on the y axis instead of as cumulative frequencies. The conversion of cumulative frequency into cumulative percents can be carried out by dividing each cumulative frequency by n and multiply by the 100. Simply you have to find out the percentage. For example, the example which I am quoting you, the total number of cases are 125. The value of n is 125. The cumulative percentage of a particular class interval is 2. Cumulative frequency of a class interval is 2. Now, what will be the cumulative frequency? 2 into 100 by 125. The value will come 1.6. What I have said, the conversion of cumulative frequency into cumulative percent can be carried out by dividing each cumulative frequency, that is 2. The conversion of cumulative frequency into cumulative percent can be carried out by dividing each cumulative frequency by n. Cumulative frequency is 2, n is 125 and multiplying by 100, it is 1.6. So, the class interval whose cumulative frequency is 2, its cumulative percentage frequency will be 1.6. It will vary on the number of cases, that is what is your n. Now, this is data before you. 24.5 to 29.5, 29.5 to 34.5, 34.5 to 39.5, 39. I have given taken the upper limits, 39.5 to the 44.5, 54.5 to 59, 59.5 to 64, 64.5 69.5, 69.5 74.5, 74.5 to 79.5. It is the frequency. First you calculate the cumulative frequency as you did in the just last case. I have taken one score, I have told you why, just to take my graph on the baseline. I have assumed it is 0. So, it is 2, nothing 2, 2 plus 4 6, 6 plus 6 12, 12 plus 15 27, 27 plus 20 47. Likewise, we will calculate the cumulative frequency. Now, we will calculate the percentage cumulative frequency. just I have told you just few seconds back, the class interval whose cumulative frequency is 2, 2 upon 125 into 100, it is 1.6. Next is 6, 6 upon 125 into 100, it is 4.8. Next, 12 upon 125 into 100, it is 21.6. Likewise, you will determine the cumulative percentage frequencies of the all class intervals. Now, you see, each interval limits is laid on the x-axis and a scale of consisting of 10 equal distance, each representing 10% of the distribution, is marked up on the y-axis, that is OY and OX. From the ogive, what is the use? From the ogive, percentiles and percentile ranks may be determined quickly and fairly. For example, to obtain P50, that is median, draw a line from 50 on the y-axis parallel to x-axis, and where this line cuts the curve drop perpendicular to the x-axis, this operation will locate the median at 51.5 approximately. The exact calculation of the median in this problem, if you do mathematically by using the formula, is 51.65. When we draw from the graph, it is 51.5, more or less the same. Similarly, one can find the value of the Q1, that is the first quartile, and the Q3, that is the third quartile. In order to find percentile ranks, reverse the process followed in the determining percentile. Score 71, for example, has a percentile rank of the 97. Now, this I will demonstrate through the graph. Now, you see, OX axis we have the upper limits of the graphs, fine, as in the cumulative. Here we have the cumulative percentages with the gap 10, 20, 30, 40, 50. So, one we have assumed just to below the lowest to just meet the baseline. Now, 29.5, the first class interval, its cumulative percentage frequency was 1.6. So, take 1.6 from OY axis and make the dot. Then next you join all the points. This graph will be called as the cumulative percentage graph, that is ogive. Now, what are its uses? As I explained you just now, with this ogive, without calculation, we can find out the value of any percentile or quartile or percentile rank. For example, you know P50 is equal to median. What is median? The point above which below 50% cases lie. So, what do? It is your C 50%. You draw a line 50, fine, and then draw a perpendicular here. On the baseline, on which score this line is meeting? This line was meeting at 51.5. So, value of median or P50 is 51.5. Without any calculation, without any formula, you have calculated the percentile. P9, if you want to calculate P90, 90th percentile, draw a line from P90, okay, then again draw. Where it is meeting, you can draw the percentile. Now, even you can draw the percentile rank. In percentile rank, you know, the score is given to you, and you have to find on the 100 where he is standing. I want to calculate the percentile rank of a student whose score is 71 or 72. Now, you see this class interval 69.5 to 75, 4.5. I want to calculate 72, that is the mid. You see the dotted line. This dotted line is for the percentile rank. Dotted line draw from here, then join it on the OY axis. Now, it is meeting between 90 to 100, and that is around, suppose for example, it is the 91. So, 97, 90, whatever it is, I will say the person who has scored 71, his percentile rank will be 97, 96, whatever the value is coming. So, with the ogive, you can directly calculate the value of any percentile, median, quartile 1, quartile 3 or the percentile rank. Now, what are the other uses of the ogive? Even with the ogive, you can make the comparison between the groups. I will show you. A useful overall comparison of two or more groups is provided when ogives representing their scores on a given test are plotted upon the same coordinate axis. A data given below shows the ogive of the scores earned by two groups children, 200 10-year-old boys and 200 10-year-old girls upon an arithmetic reasoning test of 60 items. Now, you have two groups with you, and you want to make the comparison on the same graph. By plotting, you can make the comparison. Now, I have made two lines. One is a broken line, that is for the girls, and it is the complete line, that is for the boys. You will make this graph exactly the way I presented before you. Now, take the cumulative percentages, then for the boys and the girls you do it. Now, if you want to calculate the median, now this is 50, draw. Now, this line broken here, it will be the median of the girls and it will be the median of the boys. So, if you draw two groups, three groups, you make the ogive, you make the comparison. Now, anything you want to calculate, you want to calculate the percentile rank, you can calculate the percentile rank. So, if we draw the ogive or the cumulative percentage, it will be easy not only to understand, but even to calculate the other statistics like percentile rank. Now, another type of the graph that is called pie diagram. What is pi? Pi is a 360, that is a circle, 360 degree. Now, on that 360, that is a circle, you can present the data which you have. For example, in your sample, there are 60 students of the arts faculty and then 25 students of the science faculty and 15 students of the commerce faculty. We want to make the pie diagram. So, first you will calculate 60% of 360 degree. Pi is a 360 diagram. Now, out of 360 degree, what will be the value of in degrees of the 60 cases or the 60%? That you can very easily do 60 by 100 by 360. This value is coming to 116. Then the value of 25% will be on 360 degree, 90 degree, and then the commerce students 15, it will be 54 degree. Now, the whole circle is there, make a 90 degree, that is representing the arts, then draw on the 54, it will represent the your commerce faculty, and that remaining 216 will represent the arts faculty. So, on a pie diagram, there is a circle on 360 degree, we can represent, we can show as number as possible, number of data 3, 4, 5, 6, 10 groups. So, that will give at a look, we can see that which group is maximum, which is minimum, where it is standing. So, this was all about the graphs. So, graphs are not only have the aesthetic value, they will able to understand the data easily, and by these data you can calculate further statistics with the help of this data without any calculation. So, try these graphs in your research, in your practical examination. That is all.